So let's start with our next LOS 1D. Here we'll be calculating and interpreting annualized return measurements and continuously compounded returns. So annualized returns and compounded in returns and describe their appropriate uses. These are few formulas that we will be studying. So before that, let's start with the example. So the difference between compound interest and simple interest. Let's assume there is this timeline. We are investing $100 today and at a rate of 10%. Principal is $100. And for simple interest also, this one will be representing simple interest. Here also the investment is $100. So at the end of one first year, at time is equals to 1 and time is equals to 2. My investment is going to give me a rate of, okay, before that let's discuss the formula first. So the future value as per compound interest is present value 1 plus rate to the times to the power t, and for simple interest it's principal into rate into time simply. So if I apply this thing here, the principal into rate into time, so the rate is 10%. Principal is 100, rate is 10%, into time is 1. I will divide this because this I have taken as a percentage. I will divide this by 100. So 10. 10 is my interest for first year. Again for second year also 100 into 10 into 2 divided by 100, because this I am considering as percentage. When I remove percentage, I divide it by 100. So here I am getting $20. So my investment at the end of time one is $110 because I have added it. And at the end of time two, time is equals to 2. Let me just write it like this. So my investment is going to be 120. Now, when I look at the compound interest formula, so compound interest, if I plug in these numbers here, 100, 1 plus rate is 10% divided by 100 into to the time power per. So I'm going to calculate this in a simple way. It's old-fashioned calculation. This is going to be 110. But when I talk about year 2, it's going to be 100. 1 plus 10 to the power 100. 1 plus rate divided by 10. And to the square means, this is going to be square. This means that I'm going to again multiply this thing. Same calculation here. 1 plus 10 divided by 100. And this is going to give me 100 into 110 into 110 divided by 100 into 100. 11, 121. At the end of year 2, I am going to get 121. So as per my compound interest at time 1 is I'm going to get $110. At time 2, I'm going to get $121. Now observe the difference here. There is a difference of $1. Okay, I do not have any other color option. So the difference is of $1. And the difference is created because of getting interest on interest. And this is what compound interest means. So I am getting interest on interest. Here, my investment is throughout 100. So when I calculate here, it's 100. When I calculate here, it's 100. But here, my investment is now, when I started with 100, next year I'm going to get interest on 110. So my investment is going to get 110. So this is the principal now. The principal has changed. Now again, my investment is worth 121. So now 121 is going to be my principal for next year. So next year I'm going to get 121 and In simpler ways, let me just, what does this means is, I start with 100 at time 0, at time 1, at time 2, at time 3, at time 4, at time 5. So if I'm assuming that my investment is for 5 years, so 100 is going to be there, yes. But after 1 year, I'm going to multiply it with 1.1. Next year, it's going to be 1.1 twice. 1.1 into 1.1 into 1.1 multiplied with 1.1 four times. Okay, my bad. And 1.1 to the power 5. This is what the formula represents. The difference between compound interest and simple interest. So now just remember this thing, and we will apply this in more depth. And there's going to be, okay, so now you understood the concept of compound interest. So you get interest on interest. Now, understand one thing, that the compound interest, the interest is reinvested here. So if it's time 0, if it's time 1, if it's time 2, so my 100 is worth 110 and my 100 is worth 121 here. If I increase the frequency of reinvestment, so let's assume that I am increasing the frequency not yearly, this is yearly, annual. If I increase the frequency to quarterly, let's assume that 1, 2, 3, 4. This is quarter 1, quarter 2, quarter 3, quarter. Okay. This is quarter 1, this is quarter 2, this is quarter 3, and quarter 4. So here I am investing 100 at the same rate. Let's assume here I have got at the 10% was the interest rate. The frequency annual was previously annual. Now it's quarterly. If I increase the frequency at the same rate, so my principal at the end of period 1 or at the end of the period as compared to where the frequency is larger, so that's going to be more. My interest is going to be, if I calculate it here, it's going to be more than 110. And how? So if I invest, I'm going to break this 10% into 2.5% quarterly, because this is what it's going to be. So at the end of quarter 1, I will be receiving 100 into, I I do not have much space here. Let me just try to make it a little clearer. So 100, I start with 100. 1 plus rate is now 2.5 to the power of divided by 100. And the time is going to be 1. Because I have also decreased the time here. This is the first quarter. So this is going to give me 100 into 1, 0, 2.5 divided by 100. And this is going to be my principal for first quarter. This is my principal for first quarter. I will reinvest this thing. For the second quarter, I am going to get again this thing 102.5, and I multiply this with 1 plus 2.5 divided by 100. So it is going to give me, and just like we previously discussed this thing, we start with 100. Quarter 1, we are going to multiply with 1 we are going to multiply this thing with. This is what the formula is going to represent now. Let me just quickly calculate it on my calculator. I'm showing you, like I'm sharing my screen with my calculator. So I start with 1.025, multiply it to the power 4. This is going to give me 1.1. Now, if I multiply this thing with 100, which is my principal, this is going to give me 110.38. So at the end of first year, I'm going to get 100.38. This 38 is the interest on interest. So if I increase the frequency, my principal is going to increase compared to the one situation where the frequency is lesser. Okay, I hope this is clear now. So let's move to next concept. So this concept, I hope this is clear. Now understand. Let's do one question here. So there is annualized return which are shorter than 1 year. There is annualized return. So what we have discussed here is annualized compounding and non-annualized compound. So when we use annualized compounding, the returns and the time, there is no difference. When we use non-annualized compounding, the rate is divided into the increase in the frequency. M represents the frequency 4 in our previous case when it was quarterly case. So this is actually going to also multiplied with the time also. So time is also increased now. So if I were to simply do that uh, simply I put this plug all this in the formula. So 1 plus 10 divided by the frequency quarterly 4, and the time will also increase. So it was earlier 1, now it's going to be 4. So this is what this means, this formula means. And one another way, if you look at it from a holding period perspective, let's try to calculate these things from the holding period perspective. I hope you remember how do we calculate holding period. So a saver deposited $100 in the bank account. After 90 days, the account balance is 100.75. So the saver's annualized rate of return. So what would be a saver's annualized rate of return? One thing is that you can simply plug these numbers in the formula, or you can actually calculate it using holding period. So now understand this thing, for 90 days, it's 100.75. So this is the closing balance, 100.75 simply. If I divide it by 100, this is and subtract 1, because this is how I am going to get my return. So this is going to give me 0.75. And if I if I convert this into percentage, so the my percentage would be 0.075. 0 point, no, not 0 point, okay, yes, 0.0075. So this is going to be my percentage change in 90 days. But understand this thing, this percentage, whenever I talk about percentage, the percentage numbers are basically annualized numbers. So I need to now annualize, sorry, this percentage is annual number. So now I need to annualize this percentage number. My my change, my increase or my change in account balance in percentage. And now I need to convert this thing into 90 days. 90 days means one quarter. Not one quarter, maybe. Yes, one quarter, one quarterly. So how I'm going to do this is, but I will, if they have given 90 days, so I'm going to divide 360. I'm going to use 365 divided by 90 to convert this into quarter. So if I plug these things in the formula, it's going to be 1 plus 0.0075 to the power 365 divided by 90. And we subtract 1. And this is going to give me somewhat roughly about, okay, let me just calculate this thing using my calculator. How do we calculate these kind of calculations? So it's 365 is in the numerator. It's in the, it's actually powered. So it's superscript. So let's start with 1.0075. This is one number. Now I'm going to press this key, y to the power x, and then I will open my bracket. In the bracket, in the parentheses, I'm going to write 365 divided by 90. Close the parentheses. This is going to give me 1.03. And if I subtract, so this is 1.03, and and now I actually have to subtract 1 out of this and multiply this with 100 to convert it into percentage. So this is going to give me somewhere around 3.08. 3.08 is our, so 3.08 is the required. So this is the rate. This is the 90 days rate for uh, the 90 days annualized rate of return. And one more time, let's do another question where the annualized return is longer than 1 year. So let's assume that the investor buys a 500 days government bill for 970 and redeems it at maturity for $1,000. So investors annualize return. Now again, uh, the holding period return here, HPR, we need to start our calculation from something. So we need to calculate the return, how much return we have got here. So we start with 100, those 100,000. We subtract 970. This is how much we have earned. So 970, and this exactly is represented by this formula also. So $30 divided by 970, and this is going to give us roughly a return of 0.0309, or if you convert this into percentage, it's 3.09 percentage. So the annualized return, again, we plug these things in this formula. So annualized return is 1 plus 0.0309. Now raised to the power 365 divided by 500, because this is a 500 government bill. Then we subtract 1 at the end. So now let's calculate this thing on the calculator once again. So 1.0309 and raised to the power, this is this is how we actually raise it to the power. We click on this. We start a parentheses, 365 divided by 500. We close the parentheses, we click on equals to. This is 1.02. We subtract 1 out of this. We multiply it with 100 to change it in, convert it into percentage. So this is going to give me 2.25, 2.25 percentage. 2.25 percentage. So annualized return shorter than 1 year, annualized return greater than 1 year, we have discussed. Now let's move to next annualized returns. Mm, Annualized returns, yes. We have also discussed questions on annualized returns. So this is what we have actually discussed. Non-annualized and annualized compounding and non-annualized compounding. We have uh, already discussed about these. We will apply more these concepts when we will do the questions. So now continuously compounding returns. So continuously compounding returns are those returns where the frequency is like, I mean, it's not it's it's not quarterly, it's not daily, it's not it's lesser than quarterly, it's lesser than weekly, it's less than daily also. So it's not even daily, greater than 365. So it's continuously compounding. And for continuously compounding, the formula there is a formula here. It's a little complex formula, but we actually have a function in our calculator to calculate these kind of returns. So uh, let's uh, let's start with our question here. Okay, before that, let's do one question here. The effect of frequency, the effect of compounding frequency on future value and present value. So we have previously discussed that when we increase the frequency, our returns also increase. So here, let's assume there is a question, present value is 1000, and this is to be received after 1 year at a stated rate of 6%. Okay, present value is 1000, and what we will be receiving at the rate of 6% when the frequency is 1, when the frequency is 2, when the frequency is 3. Quarterly means not 3 but 4. It's incorrect here. It should be 4. Okay, so quarterly frequency should be 4, and monthly frequency is 12. Daily frequency is 365. Interest paid, we are going to divide our interest. If the frequency is 1, no, the interest is going to be 6% only. When we look at our interest rate for two semi-annual, so interest rate is, we are going to divide our interest rate. We are going to divide it by 2. For semi-annual compounding, there is going to be a different interest rate. When the frequency is quarterly, we are going to divide our interest rate by 4. When the Because when the frequency is 12 months, monthly, we are going to divide our interest rate by 12. And when the frequency is daily, we are going to divide our interest rate by 365. So no changes here. And this is going to change our present value. Along with present value, the frequency will also increase. So here the time will be 1. The formula present value is equals to mm, future value. Future value is equals to present value 1 plus rate to the power time. So this rate is going to be divided by 2. The timing will also be double. The timing will also, we are going to multiply, going to divide it by 2, and we are going to multiply the time by 2. The present value is going to be 1000. 1 plus 0.06 to the power 1. Here the present value is going to be 1000. 1 plus 0.06 divided by 2 to the power 2. Okay, we are calculating the present value. Not This is not going to be the present value, but we are going to divide this. We are not no, okay. Just give me one moment. So present value is going to be future value divided by 1 plus r rate to the power time. So if we are calculating the present value, and here the question is stating that you will be receiving, compute the present value of $1,000. $1,000, you will be receiving $1,000. So this $1,000 is the future value here. And what should be the present value of this $1,000? If you are investing, how much should you be investing right now today to receive $1,000 in future? So the question is other way around this time. So we are going to divide it. So we are going to start with $1,000. We are going to divide it 1 plus 0.06. For semi-annual compounding, we are going to use 1 plus 0.06 to the power divided by 2 to the power 2. $1,000 divided by 1 plus 0.06 divided by 4 to the power 4. $1,000 divided by 1 plus 0.06 divided by 12. Rate is divided by 12 and to the power 12. And similarly for daily compounding also, $1,000, 1 plus 0.06 divided by 365 raised to the power 365. Let's quickly calculate this thing one by one. And you should be very comfortable with your calculator. There is a different feel when you are uh, using a calculator on your phone, or when you are actually using the calculator. So the feel is very different. So first we will solve the denominator 1.06. Yes. I'm going to inverse this thing, and I'm going to multiply this with $100,000. So this is going to give me 934. 943.40. This is going to give me 943.40. Let me just stop my share of screen. So 934.40. So how do I do this? So I first solve the denominator